Hello students, welcome back to the sixth video of this playlist. So in this video, we will be solving question number 6 from January 2024 Mechanics 1 paper. So let's see what's the question number 6 from this paper is about. Okay, so basically the concepts behind question number 6 is from projectile motion that is discussed in chapter number 2 of your Mechanics 1 textbook. So in order to be able to solve this question, definitely you have practiced sufficient questions from chapter number 2 of your Mechanics 1 textbook. So let's get started with question number 6. Okay. A particle is projected vertically upwards from a point A with speed 24 meter per second. From a point A, the particle has been projected at a speed of 24 meter per second towards the upward direction. The point A is 2.5 meter vertically above the point B. The point A is 2.5 meter vertically above the point A. Okay. So if we consider this is point B, okay, if this is point B, then point A is what? 2.5 meter above the point B, right? Point B lies on the horizontal ground, so that means point B, it lies on the horizontal ground, and the particle moves freely under gravity until it hits the ground at B with speed v meter per second. Okay, so it is moving freely under the force of gravity until it reaches the ground at point B. Fine? Okay. So this is basically the introduction to this question number 6. Okay? Okay. So for part A, before part A they said after hitting the ground, the particle does not rebound. It is not getting rebounded. Okay. So if it doesn't rebound, then in part A they are asking to find the value of V. We need to find out the value of what? V. Okay, fine. We need to find out the velocity with which it will approach the ground. Okay. So its initial velocity is known, which is 24 meter per second, right? From A it is projected in the upward direction, right? Its initial speed is 24 meter per second, right? Meter per second. Okay. And the point A is vertically 2.5 meter vertically above point A. That means when the particle will be at point B, the displacement from point A would be what? In the downward direction by 2.5 meter. Okay, so we will consider upward direction as positive, so that means downward will be what? Negative 2.5 meter. Okay, displacement is negative 2.5 meter. So we got the initial velocity, we got the displacement, and what else we know? We know the acceleration. Here acceleration is acting downward. Acceleration is happening downward because the gravity force is in the downward direction, so it will be what? Negative g meter per second squared. Okay? Okay, fine. So for part A, we need to find out the value for V. So in that case, we know we know the displacement, we know the acceleration, we know the initial velocity. So we can easily find out the velocity, the final velocity, using this formula. We took the upward direction as positive. Okay, so considering upward direction as positive, we will use this formula. V square equals to what? U square plus twice of AS. Okay, so we need the value for V. So V equals to what? Square root of what? U squared. U squared is 24 meter per second, if I'm not wrong. Yeah, 24. So 24 squared minus 2g. Why it is minus? Because g is negative, right? And displacement is what? Negative 2.4 or 2.5. It's 2.5 meter. Negative 2.5. Okay. So the value for V would be negative. Okay. We will consider the negative value of V because V is towards the downward direction and we took downward as negative. So V equals to how much? Use your calculator. 24 squared plus 2 times 9.8 times 2.5. So that would give you 625 and this is basically 25 meter per second, okay, which is negative 25 meter per second. That's the value for what? V, and that's what they have asked in part A. Okay, next is part B. In part B, they are asking to find the time taken for the particle to reach B. That means the total journey time, the journey time, that is the time required for the particle, the projected particle, to reach the ground. Okay, so in order to find out the journey time, how can we find that out? Let's consider, we know the acceleration, we know the initial velocity, we know the displacement, we know the final velocity also. So we will consider the velocity and acceleration to be straightforward. Okay, we are not considering any complex thing. Okay, one thing I missed in part A, they asked for the speed. Okay, so please correct it out. They asked for the speed and only the value for V. Okay, so V would be just 25. Okay, 25 would be the answer. Okay, and ignore the sign because they asked for the speed. Fine. Okay, so correct it out please. For part B, we will consider the upward direction as positive like as before. So acceleration is equals to what? V minus u over t, right? So velocity, the final velocity V, it's in the downward direction, so it will be what? Negative. Okay, so t equals to what? Velocity V is negative, so negative 25, and initial velocity is what? Positive. How much? Initial velocity was 24. So negative 25, negative 24 over what? Acceleration. Acceleration is negative g because downward. Final velocity is in the downward direction. Acceleration is also happening in the downward direction. Therefore, it is what? Negative 25, negative 24 over negative g. So what would be the value? Negative 49 over 9.8. This gives you negative 5. Sorry, only 5. Okay, positive 5. Time can never be negative. So t equals to what? 5 seconds. So total time required to reach the ground, it is how much? 5 seconds, and that's what they have asked in part B. Okay, so next is part C. The point C is 10 meter above A. The point C is 10 meter above point A. Okay, so part C asks to find the length of time for which the particle is above C. Okay, the particle is above C. Okay, so let's consider the figure. Okay, let's consider the figure here. We need to erase everything there. Okay, now have a look. The particle has been projected from point A in the upward direction. So this is point A. So from point A it is moving upward, and then it will reach a maximum height, and then it will start moving downward and reach at point B here, right? So point C, consider point C as in here. Okay, this is point C. So when the particle will be at point C, okay, on the level of point C, what would be its displacement from the point A? Displacement, it's what? Direct distance. We took upward direction as positive. We took upward as positive. That means since point C is 10 meter above point A, in that case the displacement would be positive 10. Okay, for part C, the displacement would be what? Positive 10. Okay, for part C we will consider the displacement is 10 meter. Okay, now we know the initial velocity. Initial velocity is 24 meter per second. We know the acceleration, which is equal to the negative g. Okay, so we will consider same upward direction as positive. We know that s equals to ut plus half of at squared. So we need to find out the time for how long it was what? Above 10 meter. That is above point C, right? Okay, so s, the displacement should be greater than how much? 10 meter in order to be what? Above point C, right? The displacement has to be greater than 10 meter. So s equals to what? Ut plus half a square. So 24t minus half of what? Gt squared greater than 10. Okay. Now what we can do? Take half of gt squared to the right. Like take all the terms on the left side to the right side. So you'll get half of gt squared negative 24t plus 10. On right hand side is basically less than side, so less than 0. Okay. Now what we can do? Multiply both sides by 2 to ignore the fractions. So here you will get gt squared minus 48t plus 20 less than 0. Okay. Okay. So we got an inequality. So we need the critical values. At critical point, what would be the case? Gt square negative 48t plus 20 equals to what? It is equals to 0. Okay. It is equal to 0. Okay. Now we need to find the critical values, right? So t is equals to minus b plus minus square root of b squared minus 4ac. b squared is 48 squared minus 4 times 9.8 times 20, which gives you 1520. Okay. 1520 over twice of a, which is twice of g. Okay. So the two possible values for t are square root of 1520 plus 48 over 2 times 9.8. So you will get one of the value for critical value is t equals to 4.438121295. Okay, this is one of the value for t, or t equals to what? 48 minus square root of 1520 over 2 times 9.8. So this is basically this is 0.459 0.459837. Okay, there are 4 8s. Okay, so we got the critical value. Now consider the derived inequality. Before considering the critical value, the derived inequality was this one, right? So this is a quadratic equation. This is a quadratic inequality. Now for solving a quadratic inequality, we know that this inequality wants the values of t such that the curve will be below the x-axis. If I show you a graph, that will help you to understand it better. So consider this is the axis, and since you can say gt squared, right? It is gt squared. That means the coefficient of t squared, it's positive. So quadratic equation, this quadratic graph would be u-shaped, right? Like this. Okay. So in that case, which part is below the x-axis? This part, right? This part is below the less than 0. This part is less than 0. So this part can be found for which t values? These t values. Okay, that means the solution to this inequality would be the t values between the two critical values. Okay, so t should be what? T should be greater than 0.460, three significant figures, and less than 4.44. okay, that much seconds. Okay, I think they have asked here for the length of time, right? Find the length of time for which the particle is above c. We need to find out the length. Okay, length of time. So we need to go for the difference. Range is not required. Length is how much? 4.44. Okay, I have the exact value. That's a benefit. 4.443 8121295 minus the answer, that would give you 3.978 something. So 3.98 seconds. Okay, for 3.98 seconds the particle will be above what? Point C. Okay, and that's what the question in part C has asked for, the length of time. We got 3.98 seconds. Fine. Okay, next is part D. In part D, they are asking to sketch a speed time graph for the motion of the particle from projection to the instant that it reaches B. No further calculations are required. So we need to sketch a speed time graph, okay, for the motion of the particle. Okay, we need to sketch a speed time graph. Okay, let's go for the speed time graph in part D. We need the speed time graph. So we know that speed can never be negative, right? So we will ignore the negative part. We don't need the negative y-axis. Okay, we will just need the positive x-axis, because time is always positive, and we will always we will have the positive y-axis also, because what? Because speed, it is what? Speed. Let me go for the next page, no problem. There's enough space to sketch it clearly. So okay, along the y-axis it is what? Speed, v meter per second. This is speed. Okay, okay, and along the x-axis this is what? Time. Okay, so initial speed of the particle was how much? 24 meter per second, right? Okay, and it has been projected in the upward direction, that is in the positive direction. Okay, the direction doesn't matter, just consider the speed. As the particle is moving in the upward direction, it is decelerating, right? Its speed is decreasing. So the speed will start from 24 meter per second, okay, and it will keep decreasing. Okay, okay, and here it reaches the maximum point. Okay, so this value is basically 24 meter per second. Okay, from here it has been projected and it reaches speed is 0 meter per second at this time. We don't need this time because the question says no further calculations is required. Then what happens? From the maximum height, the particle will be freely falling towards the ground. Okay, okay, it keeps freely falling towards the ground, and we know that initially 24 meter per second was the speed at point A, projection speed at point A. So basically point A, it was 2.5 meters above the point B, above the ground. Okay, so that means when it is falling to the ground, it is traveling 2.5 meter more distance. Since it is traveling 2.5 meter more distance, that means it will accelerate while falling for a longer period of time, and that's why it will reach a greater velocity, which is v. Okay, and we know this v is how much? We got this in part A. We got this v as 25 meter per second. Okay, so it will be how much? It will be okay. It will be okay. We can keep it here. 25. It's perfect. 25. This is 25 meter per second. Okay, and yeah, that's basically the sketch for the velocity time graph of the motion of the what? Of the particle. And are there any further levelings we need? We have the speed. Okay, what about the time? We didn't consider the time. Do we know the time required to reach the maximum height? This was for label C, point C basically. What about the time? Oh yeah, for part B we know the time required to reach the ground. Okay, what was that? Oh, it was 5 seconds. Okay, so we have the time. We have the time. So this is how much? This is exactly what? 5 seconds. Okay, this is exactly 5. Okay, time is in seconds. That's it. That's the end. Okay, that's the speed time graph for the motion of the particle, and that's what they have asked in part D of question number 6. And that's all about question number 6. That's it.